Welcome, guys. So today let's solving this H 274 H index. Okay, and actually this problem is exactly the same as another problem is 275 H index. Okay, so let me just so these two are actually the same. So let me just see the first one. So given array of integer citations, citation I is the number of citations the researcher received I's paper, and return to compute the so-called H index. So according to the definition, scientists have injected if their papers have at least H citations and N minus H paper have no more than H citation. Okay, so once I think once you see this, you know the answer. This H must into the one must the same as one of the citations. Let's say 30615. The answer is 3 because there is a 3 at you have 5, 6, and 3, right? So there are 3 papers which at least 3. Okay, so reason so that you see the answer is 3, right? So the answer must be in the citation, right? By definition. Okay. And this is 1. Okay. So one way is that one naive way is that you pick every number in the citation. Let's say you pick 3, and you ask how many numbers, how much greater equal to 3. Let's say you find 3 of them, then exactly the same, right? So which tell you that? So which tell you the criteria, right? So let's see the criteria. So the criteria is what? Let's say I sorted this array, right? So I get 0, 1, 3, 5, 6. Okay, so I first sorted, and the key. Okay, so this is the so by definition, right? This is answer. So you what is the criteria for this answer, right? So let's say this is indices. So 0, 1, 2, 3, 4, right? So I think you can see a trick, right? This is 2 plus 3 is 5, right? So actually, so the criterion is that let's say the total is n. So if n minus m, n minus m is which is indices, is the same as citations of m. Then m is the H index, is the H index. Okay, so the proof is very simple, right? The proof is that let's say n minus m citation, right? So that means the number of papers have at least m citation will be what? So this is, let's say this is m, right? The index is m, that means there's a m papers here, right? There's a right. So this m is indices, right? So so that means the number of papers have at least m citation. Sorry, at least a citation m is this, right? This part. Which is exactly what? Number of paper have at least a citation m. It's just this part, right? So it's n minus m. So exactly match this this criteria. So this is criterion that n minus the indices equals to citation m. That m is the H index. Okay, so this is the solution, right? This is the equation. So we just need to find the solution for this equation. Okay, so then we can, so that means we can use a binary search. Okay, because once I sorted this citation m is a monotone, right? So for example, I can find it. I can just use this. I can just use the binary search, and I find this exactly find answer, right? So the key is that let's say let's just write a pseudocode, right? So I can initialize the left and the right to be the length minus 1, and I first calculate L plus R divided by 2, right? So let's say while. So let's say L less than R. Okay, so there's a case that the citation of M, let's say IUC, is exactly n minus m. So then I just find answer, right? I just return M. And then there are 2 cases. The first case is that if the citation of M is n minus m, greater than n minus m. So this means what? So this means that your citation is so high, right? So right. So if citation is greater than m, citation is greater than n minus m. that means your citation is too high, right? So that means your R should be your R should change it to n minus 1. If your citation m is less than n minus m, right? So that means you're that so this means what? This means that this means this is, let's say, n minus m, right? So let's say n minus m, and your citation is here. Okay, so this means that what? So this means that you should increase your L from 0 to n plus 1, right? So okay, the reason, okay, okay. The reason, okay, so maybe if you are not easy, if you cannot immediately see this, you can just check an example, right? So for example, if m is 0, right? If m 0, that means what? That means c0 greater than n, right? So if c0 greater than n, that means it's first paper already have citation, already have the citation larger than the number of it, then you should immediately return you should immediately return the answer which you just n. Okay, so in this case, your left, your right, right, should let's see. So if yeah, if m is 0, let's say, okay, so yeah, I just don't care about it. Yeah, so this is the binary search code, right? It's very easy. Yeah, so final answer is n minus L. Okay, so this is a little bit hard to understand. Okay, the reason is that let's see special case. Why? So why n minus L? Right? So why n minus L? Okay, so let's imagine a case that this professor has the let's say total is n, right? That all the citations are greater than or equal to n. So this is n, right? Now if you use the binary search, right? Then you first search this part, and then your C of 0. Sorry. Let's say this is n plus 1. And your so this part is greater than n plus 1, right? So your R will be n minus 1, right? So your R will be here, and still so R will keep decreasing. So finally R will be what? Your R will be what? Right. So finally your R will be 0, right? So L, then this will violate this condition. So finally, so if in this case, finally your L will be 0. So answer will be n, right? Because total is n. So answer must be n minus L. Okay. Okay, so this is the part. This is the answer. Okay, so for this part, you just sort it and then you run a binary search. But this is the same as in H index 2, right? Because H index 2 is exactly as first one. It's just original sorted. So for this one, you just run a binary sort, the binary search. Yeah, I mean, you can check both of them are the correct answer. Right, go on. And you can just run it. Yeah, so basically the reason I think all the key lies in this equation. Citation m equals n minus. Okay, so see you guys in the next video.